Alright, so let's talk about reactions of aldehydes and ketones. Now, I was saying that this particular aldehydes and ketone undergoes three major types of reaction. We have the first one, addition reactions. The second guy is condensation reaction. And the third guy is we have reduction and oxidation reaction. Now there are more to this, but we are just going to be focusing only on these three. And this is the scope of 260. Alright. For the addition reaction, we have, remember I told us that each type of reaction, we have the addition, the condensation, and of course the redox, condensation and reduction. Now the reactants or the reagent that will be reacting with the aldehydes and ketone will give us an idea of whether that reaction is addition reaction or condensation reaction. Now anytime you see four of these reagents reacting with aldehydes and ketone, just know that it is what? Addition reaction. Just take note of that. Water, anytime water reacts with aldehydes and ketone as addition reaction, alcohol reacts with aldehydes and ketone as addition reaction, hydrogen cyanide and Wigner reagent. Wigner reagent is basically RMGX, alkyl magnesium halide, where R is an alkyl group, magnesium is magnesium, X can be chlorine, bromine, or iodine. Okay. Now, what is the principle behind addition reaction? Now, look at this. Let me show something. Recall that all aldehydes and ketone possess what we call the carbonyl group. They all possess what we call the carbonyl group. So please pay attention. How does aldehyde react on this? All these substances I just listed here can split into plus and minus. Water can split as H plus and OH minus. So it means that anytime aldehydes or ketone is reacting with any one of these, it must split as minus and plus. So this carbonyl group, this double bond will break, O becomes minus, C becomes what? Plus. That is it. All aldehydes and ketone, I repeat it again, I put this. Anytime aldehydes and ketone is reacting with any one of these, it must always split as minus and what? Plus. It's a must. Now, once this guy has split as minus and plus, this can also split as minus and plus so that we can exchange their charge. Water, H2O, will split as H plus and what? OH. So that the H plus goes to the what? Minus. And the OH minus goes to the what? Plus. You have your product. Alcohol has a general formula of this. Alcohol will split as H plus, RO minus. Where this R is an alkyl group, right? The plus once again goes to the minus, and the minus goes to the what? Plus. You have your product. Now, how about HCl, hydrogen cyanide? This guy will split as H plus and what? Cl minus. Once again, the plus goes to the what? They will not give you this in exam. They will just say, what is a product of the reaction when or completes a reaction? When this react, it's now in that know that anytime any of this is reacting with aldehydes or ketone, it is addition reaction. And in addition reaction, a double bond of the aldehyde or ketone will always split as minus and what? Plus. This guy will also split as minus and plus so that they can exchange their charge. Now, Wigner reagent is always splitting as NGX plus and R minus. That is how it splits. This is an alkyl group. Magnesium is a metal. So the metal is going to take the plus, the R takes the minus. So once they react with this, that is exactly what is going to happen. The H form goes to the minus, and the minus goes to the what? Plus. Now let's take this simple. So let's take the one after the other. The first one is reaction with water. I know I've done this one before now, but I want to give us two or more examples. Reactions with water. Now, what is a product when aldehydes and ketone react with water? A product is always a diol, not just anyhow diol, but geminal diol. Now, why do we call it geminal? Because the two OHs are always attached on the same carbon. Now, we'll take the first example. We have CH3, this CH3 plus water. Now, that's the first. We have the second one, CH3, CH2, this plus water. Now, let's look at both of them here. Now remember, anytime water reacts with aldehydes and ketone, it does that via addition reaction. And in addition reaction, aldehydes will actually break this double bond into plus and what? Minus. The O is always a minus because O is more electronegative than carbon. It is always going to be the what? Plus. Now water is going to split as H plus and what? OH minus. Alright, so when you do that, you come down to the product becomes CH3, C, CH3. So in place of this, your double bond, O, you break this guy, here's going to be minus and here's going to be plus. Now, water is break already as CH value. So you come here, take the H, which is plus, and add here, take the OH, which is minus, and attach to this. You have a product. Now, this becomes propane 2 diol. And it's a gem diol, geminal because the two OH is on the same carbon. Now, we look at the next example. This propanol, this is butan 2O. Alright, now the same thing is going to happen here. This will always break into two, minus and plus, and water can actually break into plus and minus. So this becomes CH3, CH2. Now you break this bond, here is minus and here is plus. Water can break as H plus and OH minus. The H plus comes to this, to form this, and the minus comes to this, to form this. That becomes the product of that reaction. Still gem diol, but this time around, this guy is actually butan 2. Please, sorry, the E will be complete. Butane 2 diol. So that is that with water. So we're going to look at that of alcohol. After alcohol, that of HCN, Grignard reagent, and we are done with addition reaction. We move down to condensation. Alright, the second reaction under addition reaction of aldehydes and ketone is reaction with alcohol. Now, it's important for us to know the general formula for alcohols and then see the various examples that can come up. So, alcohol do have the general formula ROH, and then you can have the simplest example as CH3OH. Remember, this R is an alkyl group, so I can have the second example CH3CH2OH. This is methanol and this is ethanol. We have the third guy, CH3, CH2, and CH2OH. Well, these three common examples of ethanol are the ones that most likely you're going to see in exams. Now, remember, in addition reaction of alcohol, of aldehydes, the aldehyde from carbonide is always split into plus and minus, right? That means the incoming reagent must also split as what? Minus and plus, so that they can exchange their charge. So alcohol is always splitting as RO minus and what? Please, not the other way around. So let's look at this. This R in this case is this CH3. Yeah. So this is going to be CH3 O minus and what? H plus. This guy is going to be CH3, CH2 O minus and what? H plus. Of course, you do the same thing for the last time. Alright, so having done that, we are now going to take series of examples to see how this can be added to the aldehydes and ketones. So you can actually write out the last one is CH3, CH2, So let's see how this adds to alcohols. Sorry, to aldehydes or ketone. All right. So let's look at examples. Aldehydes and ketone reaction with alcohol. So we have the first one. Give the product of the reaction when propanol is reacting with methanol. Please, this is methanol. This methanol. Now, what is the product of this reaction? Now, let's look at the next one. We use ketones. Let's use aldehydes. CH3, CH2, plus, let's use ethanol here. Now, how do we react this? This is ethanol. And this is propanol. This propanol. Now, if you look at this, if you split this guy, of course, this methanol is going to be split as CH3 O minus and what? H plus. So first, I want to get my product. Oh, alcohol reaction with ketone is going to proceed via addition reaction. In addition reaction of aldehydes and ketone, this carbonyl group is always split as plus and what? Minus. The reagents that are split as plus and minus, their charges will be exchanged to get the product. So I'll come here, I'll say CH3, C, double bonded to O. Now I want to show us how to carry out the addition. Now this guy, this double bond will come here and split. Here is minus and here is plus, right? The minus of this guy comes to the plus. Is it not so? Yeah. The plus of this guy goes to the what? So here becomes H, and here becomes what? But we are not done with that. Now, let's do the second one, then I'll explain something further. The next one is going to be CH3, CH2. Now come here. Because this is ethanol. This guy is going to split as CH3, CH2, O minus, right? And what? H plus. So once again, this guy is split as minus and plus. The plus goes to the minus, and the minus goes to the plus. This is O. Please, the bond is on the O. CH2, CH3. Please finish writing this. I'm going to explain something here for us. Now, please, I would like to explain something here. Right? Now, I said, please put it down. Note, addition of 1 mole of alcohol. Addition of 1 mole of alcohol to an aldehyde. Addition of 1 mole of alcohol to an aldehyde would give hemine acetal. Addition of 1 mole of alcohol to aldehyde will give hemine acetal, comma. Further addition of another mole. Further addition of another mole would give acetal. Further addition of another mole would give acetal. So therefore, addition of 2 moles of alcohols to an aldehyde would give acetal. So therefore, addition of 2 moles of alcohol to an aldehyde would give acetal. Would give acetal. Now let's I'm going to give us a reaction again. The first one we did, I will just added 1 mole of alcohol and it gave us hemiacetal. Now, we're going to do that for aldehyde. We're also going to do that for a ketone. Ketone will give us hemi-ketal. If I add another mole, it will now give me what? Ketal. Alright, so let's look at this. Let's use CH3. Okay, let's use aldehyde. This is propanol. Now, when I come here, I'll say plus CH3OH. This is alcohol. Now, the first mole. Now, here, this is going to split as CH3, O minus, and what? H plus. So break this guy. So have CH3, CH2, C double bond then to OH. This will break into minus and plus. The minus from this methanol goes to the plus, and the plus goes to the what? Minus. So this becomes H, and this becomes OCH3. Now this is what we refer to as hemiacetal. Now, when I add another molecule of that same alcohol, so I could come here, I can say plus, I can just write it on top of the arrow, CH3OH. Please take note that the addition of the second alcohol does not follow the same principle or the same pattern like the first one. In the first case, we had a double bond whereby we said split the double bond into minus and plus, right? Split the reagent into minus and plus and exchange their charge. But once we form this guy, there is no more a double bond for us to split. So what is actually going to happen here is more like a substitution reaction. Please look up. What I'm going to do is that I'm going to replace this OH with this. So it's just like having, let's say for example, imagine I have another molecule of alcohol here. Imagine I have this. It's just like replacing the OH of this with the what? RO. When I replace this R with methyl, it now becomes CH3O, right? So once you remove this OH, add it to this H, form water. Form what? Water. Now take what is remaining here and replace it here. Is it also? So this is what we are going to have. We're going to have, I'm going to come back to this. This is CH3, CH2, CH. Now come here, replace this OH with what? OR. Here becomes O what? R. This OH now comes up, fix up the remaining H and form what? Water. This now becomes acetal. And how do you know that? Acetal is a case where a carbon is having OR to OR. And then you know that this R is an alkyl, right? Yes. So imagine we have OR up and we also have what? OR down. That's acetal. Hemiacetal is when this carbon has OH up, one OH and one OR. That's hemi. Both for that of acetal and ketal. Hemi-ketal, the only difference between ketal and acetal is that this guy is not an aldehyde bond. If it's an aldehyde, acetal. If it is a ketone, ketal. Do you understand? Are you following? Yes. Okay, I repeat. This guy, if it's an aldehyde like we have here, 1 mole of alcohol to an aldehyde will give us hemiacetal. And how do you identify hemiacetal? A single carbon will be attached to one OR and one OH. Right? Now, I think it's best I replace this guy with, I think let's use this first. Right? Let's use this. Class, let's look at this. We said addition of 2 moles of alcohol to an aldehyde will give us hemiacetal. This is the general formula for alcohol, is it not so? And this is an aldehyde, right? Now, this becomes CH3, CH2, CH. In place of this double bond, I'll break this guy as minus and I'll break this guy as what? Remember, alcohol is always breaking as RO minus and what? H plus. The plus from the H goes to the what? minus. So this becomes OH. Now this RO comes to this guy, right? Now this is hemi acetal. A carbon is having OH and what? OR. Now I add the second mole of alcohol. I put a stroke. The reason why I'm putting this stroke here is just to differentiate this one from this. Now, please, in the second addition, it's actually not going to follow the same principle like the first one. In the first one, there was a double bond here where we exchanged the charge. In the second one, there is no double bond, right? There is no charge that is exchanged. Instead, we're going to change. Remember, this R is sent as RO hyphen H, right? So come here, replace the O. OH with what? RO. Or you can simply say, instead of stressing yourself, since O, this O here is the same thing as this O here, just replace what? In place of H, remove this H and put what? R. Take this H, put it and form what? Water. Do you understand? Just finish. Remove the H and put the what? R. This becomes CH3, CH2, CO what? I put a stroke here. And I have OR plus what? Can you now see the difference between hemi acetal and acetal? Now this is hemi, and this is acetal. In hemi acetal, carbon is having OH and OR. In acetal, carbon is having OR on both sides. So let's look at, while you're writing that, let's look at this example below. Let's replace the alcohol with methanol. So it becomes difficult. So in this case now, we have, please look up, let me just explain this, just look up. Here, remember, this is CH3O minus, and this is what? H plus, right? Yeah. Now, this becomes, split this, CH3, CH2, C, minus, and what? Plus. H is plus, comes to this O. This guy is minus, comes to this. That is hemi acetal. Now, you come and add the same molecule of alcohol, CH3, OH. What I'm simply going to do is that remove this H and put what? CH3. Because CH3 in this case is this R, which is also. Yeah. So this becomes, the second guy is a substitution reaction. It's no longer addition because you're not adding, you're just replacing. This becomes C, O, CH3. This CH3 replaces the H. Then that becomes O, CH3, and we have one H. So that is that. This is hemi acetal, and this is acetal. See? Yeah. Right. Let's continue. The next one is reaction with HCl. Now hydrogen sand. Please, today have they taught you guys particular areas in class? I'm very sure they must have taught you guys. Did they teach you guys HCl? Eh? Alright, please go. HCl is actually splitting as H plus and what? Cl minus. So just like we did previously, right? This will actually add to So let's say example we have number 1. I have CH3. I have CO CH3 plus HCN. Now this is actually what we are going to have. Remember that this is going to split as H plus and Cn minus. So we have CH3. Now when you split this guy, this is minus and this is plus. The minus, which is Cn, comes to this, and the plus comes to this. It's actually the product. Now, from here, this can be either hydrolyzed, which is using acid hydrolysis in Chem 260. Anytime you see H3O, this is hydrolysis, acid hydrolysis. Acid hydrolysis can be written as H plus and water. This is acidic hydrolysis, addition of water in the presence of an acid. So anytime you see H3O plus in Chem 260, just bear in mind that in organic chemistry, just know that it's hydrolysis. So what am I trying to do here? I'll show us. Now, this Cn is actually why we have both of this. Cyanide or nitrile can actually be hydrolyzed or can be reduced. I can actually hydrolyze nitrile to carboxylic acid. What do I mean? Once you react compound that contains Cn with hydrolysis H3O plus, now this converts this guy from Cn to COOH. Converts it from what? Cn to what? That is hydrolysis. Now, let's put down the product here. So I'll say we have hydrolysis. And what do we use for the hydrolysis? O3 plus water and acid. In exams, if they want to ask something like this in exam, they will not put this. They will just put what? H3O. Anytime you see this one is what? Hydrolysis. And this part that I circled is actually the subject of this further reaction. So we have CH3, COH, CH3. This Cn will now become C what? OH. So hydrolysis will actually convert nitrile to carboxylic acid. Take note of this. Hydrolysis of nitrile will always give us what? Carboxylic acid. Now, for the reduction, class, listen. For the reduction of nitrile, nitrile is actually compound that has triple bond between the carbon and the what? Nitrogen. And reduction is addition of hydrogen. Right? So if you come here, you add hydrogen here, there is H here and there's what? H. I remove one of the bond, I've added hydrogen across. I come here, remove this bond, put H and also put what? H. So when I reduce Cn, this is what I'm going to have, CH2, NH2. So reduction of nitrile will give us amine. Will give us what? Amine. Because this place, there was a triple bond here. Reduction means addition of hydrogen. For each of these lines I remove, I'll put hydrogen across both sides. One on the carbon, one on the what? Nitrogen. If I remove the next one, I do the same. At the end of the day, I've added 4 hydrogens, right? 2 to the carbon, 2 to the what? Nitrogen. So when you reduce nitrile, you're going to get amine. When you hydrolyze nitrile, you're going to get carboxylic acid. So the product of this reaction becomes CH3, COH, CH2, NH2. Plus, that is the product of that reaction. First, if you add HCN to this, it's going to give us the compound that contains Cn and OH. We call this compound what's the name again? Let me just quickly. Yeah, this is cyanohydrin. Cyanohydrin. Cyano because CN, OH because hydrin. So I'm just going to clean up this and I'll give us a new reaction for you to give me the complete set of this. All of them. So please write. Now, so let's name this compound. Let's name this compound using the arrow path name. All right. So let's take off this first, and let's take off this. So let's name this particular. Please listen. Cn is takes priority over OH. Anytime Cn and OH is present in the same compound, OH is not named as all. OH is named as hydroxide. It's now a substituent. So this now becomes number one. This takes priority over OH. So this is number 1, 2, and 3. And Cn is named as alkane nitrile. This is the aliphatic name of Cn. It's named as alkane what? Nitrile. The alkane depends on the number of carbon contained in the parent chain. So if I start on this is 1, 2, 3. The parent chain contains 3 carbon, right? Yeah. As carbon 2, there is a substituent, CH3, and also what? OH. So this becomes 1, 2, 3. 3 carbon alkane is propane. So the parent name of this is going to be propane nitrile. But on carbon 2, we have methyl and we have hydroxy. Alphabetically, methyl is starting with M, hydroxy is starting with H. M and H is come first alphabetically. H. So this becomes 2 hydroxy, 2 methyl, propane nitrile. This is the name of this compound. 2 hydroxy, because on carbon 2 of this there is hydroxy. On carbon 2 of this there is methyl. And of course, the parent name is propane nitrile. Do you understand? Yeah. Now, we look at this next compound here. COOH is number 1 functional group in organic chemistry. That means anytime it is present, every other functional group becomes a substituent. So this takes priority over this guy. So the parent name is 1, 2, and what? 3. Compound that contains COOH, we need that we can want to reach it. It's named as alkanoic acid, right? So this is 2 hydroxy, 2 methyl propanoic acid because it's 3 carbon. So we have 2 hydroxy, 2 methyl, propanoic acid. Please, let's hold on. Please, before you actually start writing, hold on. Let's name the last one so I can just step aside for you guys to write. Please look up. Is this stop capturing this side? Don't worry. Now, in this case now, let's name this guy. I'm going to start from carbon 1 here. If I start from here, remember, OH, between we have 2 functional groups, major functional groups. We have OH and we have NH2. Alcohol and amine. Is it also? Yeah. OH, alcohol takes priority over amines, unlike CN, whereby CN takes priority over this guy, right? Yes. But in the case of OH and NH2, OH is taking priority over NH2, right? So anyhow you want to number this parent chain, this carbon is going to be carbon number 2. If you start from here 1, 2, OH is at number 2. If you start from here 1, 2. So since OH is at number 2 position from both sides, right? It is now best for us to start from the side that will give this guy the smallest number. Because if you start from here, OH, which is the principal in this case, is number 2. If you start from the OH is still number 2. So whichever side you're starting from, OH is what? Number 2. So it's best since OH is already settled. Let's now consider this second guy. We are only considering the second guy because OH is already what? Settled from both sides. If this side gave OH the smaller number, maybe 1, I'm not interested in whatever this guy will be. I'll just number it like that. But since this guy is 2 from here, 2 from here, so in that case, OH is already settled, right? So I can now choose to start from this side. So this is 1, 2, 3, right? As carbon 1, amino, this NH2 as a substituent is named as amino. Just like OH as a substituent is named as what? So NH2 as a substrate is named as what? So on carbon 1 we have amino, on carbon 2 we have methyl, which is this guy. Methyl. This is no longer a substituent. This compound is going to be propanol. Because the parent chain is 1, 2, 3. Propan 2 all because the odd is at number what? 2. On this number 2 we have methyl, right? On number 1 we have what? Amino. So in terms of alphabetical order, A and M, which one come first? So this becomes 1 amino, 2 what? Methyl, propan 2. Oh, so that is the name for this guy, right? We get a name. All right, he's right.